Hi, my name is Dean Still, and I'm with Alphabetcho Research Center. This is biomass and climate change health, but obviously a lot of more holistic metrics are involved in a successful stove. Unfortunately, there's a lot of bad press about wood, and it's well deserved. The Guardian reminds us that residential wood burners cause nearly half of urban air pollution cancer risk. In Athens, they found that wood smoke is more important carcinogen than cars because so little smoke causes problems. Even a little smoke inside of a house is really bad for you. And that has made people say that you just stop burning wood. That's the bottom line. Same thing is true with cook stoves. And ProPublica wrote an article that had a lot of influence where millions of lives were at stake. Hillary Clinton was on board, money poured in. But after a while, when scientists followed up these stoves that were in use, people thought that those experts, that propane stoves are the best answer, and that that biomass can be used to improve health is rejected as a hypothesis. That is true because the biomass stoves in use are unimproved, and so when you test them, you get bad results. Improving biomass stoves continues to be a problem. As we remember, Dr. Kirk Smith said, well, just switch from wood to gas. And that seemed like a great idea at the time. So people followed suit. They said, right, biomass is not included as a clean fuel, and we should switch. But now with climate change, most electricity, all LPG, all natural gas, all alcohol derived from fossil fuels emit dangerous amounts of CO2, which is responsible for climate change. New York City just became the largest city in the US to ban natural gas in new buildings. 50 other cities in California did the same thing. The Sustainable Development Goal says, hey, you got to use clean fuels. But now that, quote, clean fuels are fossil fuels that are being banned in the US and that are causing climate change, what do we think that Kirk Smith would recommend we do now? Biomass and climate change. Once you look at the graph, and you can see the gray is the CO2. And so when you burn wood, if the wood is renewable and the CO2 is carbon neutral, then a large part of what would be climate forcers is not hurting the planet. And so the wood has to be renewably harvested, it has to be burned very cleanly, and then we can consider it to be carbon neutral. Black carbon is 600 times more powerful, a climate forcer compared to CO2 by weight. But all of these things pointing out that, like say the fan stove in the middle, all right, if we could get wood to be burned like that, maybe energy from wood is usable and helpful. Again, unfortunately, we have had a long way to go to make stoves, both residential and cook stoves, be clean enough. And the rules that govern both were so lax that manufacturers built stoves that met the rules, but the rules meant that you could still pollute. And so we need to improve both residential and cooking stoves to to meet a goal of protecting health. And preliminary lab tests of a heating stove prototype here at ARC. Yes, we reduced emissions by 85%. The same bottom air approach, the jet flame, has similar results in open fires when tested in the lab. We can also add secondary air. And so, yes, there are ways in which stoves can be improved and maybe get wood burning to be helpful both in the US and in other countries. We have funding from a DOE grant at Oregon State University in Upper Vetro. So we are going to optimize forced draft mixing in a residential heating stove. And of course, we'll continue to do the same thing in cooking stoves. When you look at industrial biomass combustion, you have to add post-combustion to make it meet very strict regulations. And so there are three ways to do that. There's a catalyst, there's filtration, and then there's electrostatic precipitation. And we like electrostatic precipitation, ESP. You can see in the diagram here that you put a negative charge on the smoke particles, and then when they pass close to a positively charged plate, they're attracted to the plate and can't go up the chimney. We've been messing around with this for 3 or 4 years. You have to have automatic cleaning, but except for that, this is a well-known technology that's been used for a very, very long time. And so we're lucky that we can combine clean combustion with post-combustion. And for residential heating stoves, that is probably going to be part of the solution. The multi-tiered framework hopefully could result in stoves that are better adapted to markets and to users. ISO was great and included thermal efficiency, PM 2.5, CO, safety, and durability. Great start. The World Bank in 2020 added convenience, availability, and affordability. Fantastic. Now Biden's in office, the world is changing, and climate is obviously a big important part of our considerations, and so ARC added climate, which results in this very pretty 8-sided mandala of many metrics that maybe would be helpful in creating consumer-based acceptable stoves. The end of the fossil fuel era reinforces biomass as a possible renewable energy source for humanity. And so let's continue working. It's still fun. As we move into the decarbonized world, it's possible to think about biomass helping in many different ways. There are established markets in many countries for biomass. Government assistance could help to replace the really dangerous heating and cooking stoves that are in use. Eating and keeping warm are things that people will pay for and that are essential creature comforts. It's possible, when I think about this, that biomass residential heaters, cook stoves, water heaters, clothes dryers, who knows, may become fossil fuel, post-fossil fuel era products in lots of countries. And the carbon neutral requirement may considerably widen the work of the stove community. So we are challenged, but we may be facing a very interesting and effective future.